Okay, guys. So in Unit 5C, we're going to talk about statistical tables and graphs. And this is a pretty nice section. I think most of you will like it. It doesn't cause too many problems, and it actually makes sense. It's trying to get you a little bit better at reading tables and graphs. Okay. So one of the first things we're going to talk about is a frequency table. A basic frequency table has two columns. The first column lists all the categories of data, and the second column lists the frequencies of each category, which is the number of data values. So when we talk about frequency, we're talking about how many times it occurred. So whatever the category is, we're going to say how many times that occurred. We'll call that a frequency. Okay. Relative frequency is the relative frequency of any category is the fraction or percentage of the data value that fall in the category frequency in a category divided by total frequency. So this is a fancy way of saying that basically however many however many frequencies you have for a certain class or a certain category, you divide that by the total number of items in your table or in your data, okay? And you're going to get some fraction and you'll get some percentage or decimal, and that's what the relative frequency is. Now, cumulative frequency of any category is the number of data values in that category and all the preceding ones. So this one basically takes a category and adds all the ones up that came before it. Okay, so what I'm going to do is, well, we'll read this and then we'll do a couple examples. Okay, so it says types of data types and binning. So qualitative data consists of values that can be placed into non-numerical categories. So qualitative data is data values like, red eye or blue eyes, green eyes, hazel eyes. So that's qualitative data. Okay, quantitative data represents counts and measurements. Okay. So when dealing with quantitative data categories, it is often useful to group or bin the data into categories that cover a range of possible values. So one of the problems I'm going to do today, I'll show you that. I don't call them bins in my statistics class. We call them classes. But if this book wants to call it bins, that's fine. We can do that. Okay, so what I want to do is I want to come over here and I want to give you guys an example problem. I kind of don't like the ones I have in the notes right here. So let's say we have so suppose we have a physical therapist. So suppose we have a physical therapist, okay, and they want to get a sense of what type of rehabilitation is required by her patients, okay? So in order to do this, she obtains a simple random sample of 30 of her patients and records the body part requiring rehabilitation. So they give us this table where it says body part. I just kind of gave you the background story so I don't have to write it all out. So body part that needs rehabilitation, okay? And the frequency, how often, how many patients had this particular need frequency, okay? Let me see here, frequency. Yep, okay, I want to make sure I spelled it right. Okay, so first things first, we'll do back. How many people had back pain, okay? Next one, next one, next one, next one, next one. Okay, there's more than that, wow. Maybe I need to make this a little bit smaller. Okay, so I'm just going to draw a little table real quick right here. So we got back pain, we got wrist pain, we have elbow pain, hip. I shouldn't say pain. These are what needs rehabilitation. Sorry, I kind of got carried away. Shoulder, knee, hand, groin, neck. Wow, I did it perfect. And then the total number. Okay. So there were 12 people that came in for back rehabilitation, 2 people for wrist, 1 person for elbow, 2 people for hip, 4 people for shoulder, 5 people for knee, 2 people for hand, 1 person for groin, and 1 person for neck for a total of 30 patients. So remember, a physical therapist takes a simple random sample of her patient list, right? So, and again, that means that she took a sample of 30. So we're talking about a statistic. And keep in mind, this is not her whole practice. She has more than 30 patients. Okay. So she's just taking a sample. And then maybe we don't know the reason she's doing this. Maybe she has like $30,000 she wants to invest in new equipment. And she has to decide how she can serve the majority of her patients or something like that. Okay. Or kind of gather data on what does it appear most people need help with rehabilitation for, okay? So this is a frequency table. All right, so what we could do is I could extend this out, and I just want to show you guys something. So we could extend this out and make another part of this table. So this is frequency. And what frequency means, once again, is just how many times it occurred. Now, if I wanted, I could do relative. So I'm just going to go over here and I'm going to do relative frequency. So I just wanted to kind of show you guys what relative frequency actually means. They worded it in such a way that it makes it sound like it's fancy. All you do is you take the total amount, 30, and how many experience back rehabilitation, 12. So I just do 12 by 30. I take out my calculator and I do 12 divided by 30 and I get 0.4. Okay, so let's do 2 decimal places. Okay, so I get 0.4, 12 out of 30. Okay, now the next one for wrist, we have 2 out of 30. Okay, so 2 divided by 30 on my calculator, I get 0.066, and let's round off. You know what, I better do 4 decimal places on these. Okay, 0.0067. Okay, now the next one, that's too many decimal places for our class. I'm just going to go ahead and say, let's do 2. So this would be 0.067. So let's go 3, I guess. I just can't help it. I don't want to be so inaccurate that it doesn't work at the end. So I'll just do 3 decimal places. Okay, so the next one is 1 out of 30. And you guys notice all I'm doing is I'm taking how many and I'm dividing it by the total. And that's what makes it relative frequency. So this one I took 2 and divided it by 30. This one I took 1 and I divided it by 30. So I could go down and write all of these. 2 divided by 30, 4 divided by 30, 5 divided by 30, 2 divided by 30, 1 divided by 30, 1 divided by 30, and then we have all of them. And then I could just do 1 divided by 30, and I get 0.033. 2 divided by 30, we know is 0.067. 4 divided by 30 is going to be 0.133. 5 divided by 30, 0.167 if we round off to 3 decimal places. So I'll put round to 3 decimal places. Okay, and 2 divided by 30 we already know is 0.067. 1 divided by 30 we already know is 0.033, and then 0.033. Okay, so this is our relative frequency. So if they ask me for a frequency table, I would give them this, right? So this is my frequency table. But what if they said, I need a relative frequency table? Then I got to add this other section over here, okay? So that's what makes it a relative frequency table, okay? So hopefully that makes sense. Now, what would make it cumulative frequency is cumulative, you would just take and you would add, I think I'm going to do another problem for it actually. You would just take and add up. So if I said, what's the cumulative frequency for this table? So it would be 12 and 2 would be 14. So right here, we would put 14, then we put 15, then we put 17, then we put 21, then we put 26, then we put 29. Oops, I'm sorry, 28. Plus another 1, we'd get 29. Plus another 1, we get 30. So the thing about a cumulative, oops, and right here you'd get 12. So the first one would be the same. I guess I'm just going to add it since I already did it. Okay, so we'll call this cumulative. So let me make sure. Cumulative. So we have cumulative frequency, and all cumulative frequency does is it takes the number, puts it right here, and then for the next one, you take this one plus this one, and it gives you 14. Then you take 14 plus 1, and it gives you 15. Then you take 15 plus 2, and it gives you 17. So on and so on. And you will always end up with the total. See how the total matches the last one? Because what cumulative frequency is telling you is you're going to add all the ones that came up before it, okay? But again, this is probably not the ideal way to do cumulative frequency, because normally in all the problems I've always done, you add up, it normally goes by classes. So I'm going to pick a better example for this one. So let's just kind of do that. But that's what cumulative frequency would look like. You just add everything up, everything that came before. But normally you do it when you have quantitative values, okay, that hold numerical value. Okay, so qualitative data consists of values that can be placed in non-numerical. So we already talked about that. When dealing with quantitative data categories, it is often useful to bin. So I will call them oftentimes classes. So I already spoke about that. So it says classify each of the following types of data as either qualitative or quantitative. So brand names, let me move ahead here. Brand names of shoes in a consumer survey. So is that something that's numerical, or is that something that is almost like descriptive? Okay, so let's look up here. Qualitative consists of values that can be placed into non-numerical categories. So I would say this is definitely qualitative, right? Brand names are non-numerical, so this is qualitative. Okay, and then heights of students. Well, heights of students is definitely numerical, so this is quantitative. Okay. So here it says classify each of the following. So this is a continuation. It says audience ratings of a film on a scale of 1 to 5, where 5 means excellent. So now here's the thing. 1 to 5. Okay, so even though these values, they make you think they're a number, doesn't 1, 2, 3, 4, and 5. So if I told you the movie was a 5-star rating, does that mean the number 5, like it has a numerical value, or does 5 have a representation of a good rating, right? Or if you're buying something from Amazon and it is a 4-star rating, is that a good rating or a bad rating? Not because of the number 4, but it's because of what we attach to the idea of a 4-star rating or a 5-star rating. So these are definitely, or not definitely, but I would lean more towards these are qualitative values. So we go up here and it says qualitative values consists of values that can be placed in non-numerical categories. So even though 1, 2, 3, 4, and 5 are technically numbers, it's not the number themselves. It's what does a 5-star rating represent? It's an opinion, right, of good or bad movie, okay? These are qualitative despite being numbers. So the problem might be trying to trick you to make you think it's numerical just because it put numbers in there. Or just like somebody's jersey. If a basketball player has the number 32, the number 32 doesn't hold a numerical value. It's basically a replacement for the name. So you can say, oh, I'm going to cover number 32. And everybody knows that that's that individual. Okay, so that's what would be qualitative. And even though it's a number, it's not quantitative in that case. Okay, so right here, this is what they mean by creating bins. They kind of did it weird. I always do it from smallest to biggest. So normally I would have the 70 to 74 here, okay? But that's okay, we can go with this. So what they did was they created these, what they call bins, I call them classes. So they call it bins, I call it classes, okay? But either way, what they did was they separated these values, okay? So it says, consider the following 20 scores from a 100-point midterm exam, 76, 80, so on and so on and so on. Determine appropriate bins and make a frequency table, including columns for relative and cumulative frequency. So what they did, and on the exam, you know, or the quiz, I may give you raw data and then ask you to create this table from scratch or match it to a correct table. So what they did was they chose to do it in terms of 5. So the class width would be 5, because to go from 90 to 95 would be 5. To go from 90 to 85 would be 5. You see how each one of them is the same distance apart? Or just like here, 90 to 99 to 94 is 5. This is 5. This is 5. You see? So that's something called class width. We're not going to cover too much of that, but that's from statistics. Okay. And what they're telling you is the scores from 95 to 99. So let's find a 95 to 99 right there. There's a 98, and that's the only one I see. So they put a 1. Now let's go from 90 to 94. So let's see here. Here's a 94. That's 1. And then here's a 91. So that's 2. I don't see any others. So that's why they put 2. Okay. 85 to 89. Let me see. Here's 1, 2, 3. So that's why they put 3. 80 to 84. Here's 1, 2, 3. I'm missing one. Oh no, there's only 3. Okay. And then 75 to 79. So here's 1, 2, 3, 4, 5, 6, 7. And that's why they put 7 right there. And now 70 to 74. 1, 2, 3, 4. And that takes care of everything. So we've used everything up. Now what they did was there were 20 values. So they did 1 divided by 20. They did 2 divided by 20. They did 3 divided by 20, 3 divided by 20, 7 divided by 20, 4 divided by 20. And then these are the percentage, or I should say, these are the values they got when they did the division on their calculator. And then these are the percentages when they convert them. So it looks like they want to do it nice and clean. Oh, all of these numbers actually do turn out clean because you can just multiply by 5. So that is a frequency table. Then it's a relative frequency table. So once again, if they just ask for frequency, right? If they just asked us for frequency, we wouldn't see any of this, right? If they just asked us for a frequency table, you would just see that little part right there. Now, if they ask me for relative frequency, we wouldn't see this, okay? And then if they ask me for cumulative frequency, now I'll do cumulative again. So we have a frequency of 1 and 1. But now the next one is technically 1 plus 2, which would be 3. Now the next one would be this 3 right here, this 3, plus this 3 gives me 6. Now this 6 plus this 3 gives me 9. Now this 9 plus this 7 gives me 16. Now this 16 plus this 4 gives me 20. So what they're doing with cumulative frequency is they're taking the values here to get this guy, the values here to get this guy, the values here to get this guy, the values here to get this guy. And then this to get the last one, they take all of them, and that gives you 20. So that's what cumulative means. It means it just adds up all the categories that came before it, or the classes, with that frequency number, okay? So hopefully you guys are okay with that. A bar chart shows each category with a bar whose length corresponds to its frequency or relative frequency. Pie charts are used primarily for relative frequencies because the total pie must always represent the total relative frequency of 100%. The size of each wedge is proportional to the relative frequency of the category it represents. So a lot of times when you see pie charts, it's always in terms of percentages, like this percent, and that's what relative frequencies are, right? Relative frequencies are percentages. It's fractions that you divide, and then you get some decimal, and then you convert that to a percent. Okay, so here's just an example. Now again, a grade of A, B, C, or D, right? That is a qualitative data value, okay? So they're going to use a bar chart and a pie chart to show you, but they need to convert this to relative frequency in order to give us this pie chart. But we'll get to that in a second. Oh, I think they actually use it for, oh yeah, see, they even want relative frequency for both. So what I could do is I could just add another category right here. Just like this, right? And then I could call this relative frequency. I'll just abbreviate it. Okay. And all I have to do is I just have to say, okay, oops. Well, that seems pretty small, but oh well. Okay, so let me see if I can write really small in here. Okay, so 4 out of 25, 4 out of 25, 7 out of 25. You know what, that's just too small. I just can't do it. Let me let me do this again. Okay, so we're gonna go like this, like this, like this, like this, like this, and then we're gonna go like this and like this, and we're gonna call this relative frequency, and we're gonna use this red. And again, there's a total of 25, so whenever you're doing relative frequency, you just take each of the frequencies and you divide them. And remember, you don't add them because that would be cumulative frequency. Okay, so 4 out of 25 would be what? That would equal 0.16. 7 out of 25, that would equal 0.28. This would equal, what would that be? 0.36. This would equal 0.12, and this would equal 0.08. And if you want to write this as a percent, this would, let me just put percentage. This would be 16%, 28%, 36%, 12%, 8%. Okay, so now what we're going to do is we're going to take this information and we're going to create a bar chart. So for the letter grade of A, we got a 16%. Okay, but we also could look at it as a frequency of 4. So right here, you see how they have 4 right here? Here's the letter grade of A. But if I look over here, and if I just kind of keep walking over here, look what number I hit. 16%. So it lines up. So this one's actually doing relative frequency and frequency on the same bar chart. Okay, so that's pretty cool. I haven't seen that in a long time. So now if we want to say, okay, 9. Okay, so for the letter grade of C, we get 9. So if we look over here at C, there's a height of 9, but then look at the percentage of relative frequency. It's 36. Look what this is, 36%. So it's lining up perfectly. We can do the same thing with the bar chart. We know everything has to, I'm not a bar chart, a pie chart. Everything has to line up to be 100% or add up to be 100%. So we're going to just kind of do our best to approximate it. So we have this, that looks about 16%, that looks about 28, and that's all they do. It's just kind of hard to cut it up yourself without like some kind of graphic or a template. But yeah, they're just, I hopefully you guys can kind of see how these are designed. It's not too bad. Those are probably two of the most common graphs that most people are very familiar with. Okay, so important labels for graphs, title, caption. The graph should have a title or a caption or both that explains what is being shown if applicable and lists the source of the data. That just kind of makes it more believable. You know, if you want to be considered a respected source, then you should be citing where you're getting your information from. Vertical scale and title. Numbers along the vertical scale should clearly indicate the scale. So you see here how if they didn't tell me relative frequency, I wouldn't know where they're getting these percentages. But because they labeled it as relative frequency, I know that they're using this from this part of the graph. They're using the relative frequency that are created. This side, it says the frequency, so then I know that they're using this column right here. Okay, so hopefully that makes sense. Horizontal scale, the category should be clearly indicated along the horizontal axis. Tick marks are not necessary for qualitative data, but should be used with quantitative data. And so if you look at the bar chart, you notice how they didn't do like this. But normally with quantitative, they would do something like that, okay? Multiple data sets are displayed on a single graph, include a legend or a key to identify. That's kind of no big deal. Okay, let's see here. Histograms. So histograms are oftentimes used with frequency tables and relative frequency. It kind of looks like a bar chart, but normally they use classes and it's for quantitative data, not qualitative data. I shouldn't say normally, I think always. And histograms normally touch. So you see how a bar chart is separated? Normally histograms, the bars touch each other and they're built one right after the other because all the classes connect or all the bins connect. Okay, so a histogram is a bar graph for quantitative data categories. The bars have a natural order and the bar widths have a specific meaning, and the bar widths are the same. They're always the same width. Okay, line chart, you guys can kind of see that. Time series graph is a line chart or a histogram in which the horizontal axis represents time. Pretty straightforward. So these are some examples of a histogram and a line chart. So if we look here, this histogram, what they did was they split up the test scores. So let's go way back up here to this example. So remember how they said 70 to 74 and they had a frequency of 4? Let me see. Let's go way back up here or way down here. See how they go from 70 to 75? Well, they say 70 to 75 because the next category starts at 75, right? See, the next one starts at 75, then the next one starts at 80, then the next one 85, the next one 90, and the next one 95. So those will be all of the starting points of the next bar in the histogram. Okay, so here's the 75, here's the 80, here's the 85, here's the 90, here's the 95, and then the 100 is the very end. And notice how far apart each one is. From here to here is 5, from here to here is 5, from here to here is 5, from here to here, so on and so on. You guys get the idea. So this is how you can create a histogram. So they use the categories to separate, okay? And then we want to know, well, how many 70 to 74s? Well, they said 4. How many 75s to 79s? They said 7, right? So I have a 7, I have 4, I have 3 here, I have 3 here, I have 2 here, and I have 1. So I have 4, 7, 3, 3, 2, 1. And if I go look, oops, I think I did it the way I normally do it, the backwards way. So here's 4, 7, 3, 3, 2, 1, just like I have here, but I think I wrote it upside down. So here's 4, 7, 3, 3, 2, 1, because I always go with the smaller value as the top part of the table. But you guys, I think, get the idea. Okay, so let's see here. And then this is a line chart. I've also seen these called frequency polygons. This looks more like a frequency polygon to me. Or your book calls it a line chart. And with the frequency polygon, I think they didn't go into that because shows the data values for each category as a dot, and the dots are connected with lines. For each dot, the horizontal position is the center of the bin. So basically think of it as a midpoint. So notice here, what's right smack dab in between 70 and 75? It would be 72.5, right? So they put that right there. What's right smack dab in the middle of 75 and 80? The midpoint, actually, it's the midpoint of the bins. So the midpoint of 70 to 74 would be 72. So this would be 72 right here. The midpoint of 75 to 79 would be 77. The midpoint of this would be 82. And then what would that be? 87. This one would be 92. And this one would be 97. Now I stopped calculating because I saw the pattern. If you guys look, how far apart are 72, 77, 82, 87, 92, and 97? They're all 5 apart, just like the class width is 5 apart. So once I saw that, I just said, oh, okay, I can see how to separate these midpoints. And then if you look straight up from your midpoint, that's where this point occurs. We go straight up to our midpoint. Oops. That's where this point occurs. Straight to our midpoint, our midpoint, our midpoint, and our midpoint. So hopefully you guys see that this, and again, I've never seen this called a line chart. I've always heard of it as a frequency polygon, but I think in your book, they're gonna call it a line chart. So that's okay, we'll just go with that. So it says the table shows the ages at the time when they won the award, okay? So make a histogram and a line chart to display this. Okay, so let's try this on our own. So why don't you guys pause the video, create a little histogram right here, and let's see how it goes. Okay, so 20 to 29. So what are we going to do here? Let's do 10, 20, 30, 40, 50. Oops, I guess it's got to be bigger than that. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. So this is going to be 10, 20, 30, 40. You do your best to try to keep them split up, but evenly. But, you know, we're only human. We can't draw perfect like a machine. And then let me see. It goes 14, 34. So I think we could separate it by tens, and we should be okay in frequency. So frequency is always the y-axis. So frequency is always the y-axis for histograms. okay? So let's go by tens, 10, 20, 30, 40. And again, the biggest value is 34, so we should be okay. So I'm just gonna go 10, 20, 30, 40, and let's call this our frequency. And then this is the age group, I believe. Make a histogram, the ages. So this is ages down here, okay? So now what I'm gonna do is I'm gonna create a histogram, okay? And the histogram says that we have from age 20 to 29. So I'm gonna start right here, and there were 32. So I'm gonna say 32 is gonna be right about here somewhere. So I'm gonna go from 20 to 30, but I know it's actually 29, right? Then let's go from 30 to 39, that would be 34. So that's just gonna be a little bit higher. And let's go over here. Okay, and then the next one is from 40 to 49, that's 14. So that's gonna be right about here somewhere, right? Okay, and then the next one is from 60 to 60 or 50 to 59. That'll be 2. So that's going to be really low. I'm going to have a hard time drawing it, but I'll just do my best right there. And then from 60 to 69, we're going to do 6. So that'll be like right here. Okay, and then from 70 to 80, we have 1. So I'm barely even going to draw a line like that. And then from 80 to 89, we have about 1. So that is my histogram. Okay. That's how I would draw my histogram for this graph, okay? Now, and this is my histogram. And that's how you do it. You just set up your x-axis, you set up your y-axis, and then you kind of label everything. And remember, the y-axis always is frequency for histograms. As far as I know, that's the only way I've ever done it. Now, if you wanted to, they ask us to also make a line chart. So what I could do then is, if I wanted to get fancy with it, I could take the midpoint of each class. Now, there was nobody from 10 to 20, right? There is not even a 10 to 20 category, or I'm sorry, 10 to 19. There's not even a category 10 to 19, so there was 0. So that's the midpoint. Let's do the midpoint right here, midpoint here, midpoint here, midpoint here, midpoint here, midpoint here, midpoint here. And let's connect this. So this would go boom, and you connect it with line segments. Okay, and that would now be my frequency polygon or line chart. Okay, so hopefully that explains that one pretty well. I just wanted to go through one of those with you. Okay, so and this is our answer. This is what we ended up getting, and it matches perfectly. We did great. Okay, so hopefully you guys got the same thing. That's kind of a rough overview of this section. This is a much quicker section than the previous one. I just really like graphs and interpreting tables and everything. So definitely you'll see some questions on our next exam from this chapter. It's really kind of fast, and being able to read data and interpret graphs is very important, not just in math, but in general. Because it kind of, that old saying, a picture is worth 1,000 words. So if you have a picture of it, or if you have a table of it, it really can make you quickly analyze and assess what's going on. But that's going to do it for this video, guys. Thanks for watching.